So the main objective of virtual labs is to provide a remote access to labs in various disciplines of science and engineering. And these virtual labs would cater to students at undergraduate level, postgraduate level, and as well as to the research scholars, and to provide a complete learning management system around the virtual labs where the students can avail the various tools for learning, including additional web resources, web lectures, video lectures, animated demonstrations, and self-evaluations. So virtual labs will be made more effective and realistic by providing additional inputs to the students like accompanying audio and video streaming of an actual lab experiment and equipment. So now may I request Mr. Prateek Sharma, Senior Field Engineer and a mentor of virtual labs, to please take over the workshop further. Over to you, sir.
Thank you, ma'am. So first of all, a very good afternoon to each and every participant present.
Over to you.
Yeah, am I audible?
Yes, sir.
Okay, great. So greetings from Virtual Labs IIT Delhi, and today we have gathered over here to understand about this Virtual Labs platform. So let me just quickly brief you how this particular session will proceed. Now, first of all, there would be a small presentation part.
You are not audible.
Ma'am, I think you are unable to hear my voice. I hope apart from ma'am, everyone can hear me.
Yes, sir, you are audible, sir.
Now audible, sir.
Okay, thank you. So I was talking about how this particular session will proceed. So first of all, there would be a small presentation. In that particular presentation, we'll get the basic idea and the features about virtual labs. And after that, we'll move to the demonstrations part. In the demonstrations part, we'll see that how a user can simply sit at their own place and explore all the experiments virtually. Now, after this particular presentation and demonstrations part, in the end part, we'll go for the Q&A session. So now I am simply just sharing my screen, and let us quickly begin with the session. Okay, I hope my screen is visible.
Yes,
Can
sir.
anyone please respond? Okay, thank you. So virtual labs, a very great initiative by Ministry of Education, which was formerly known as MHRD. We are all very well aware of that. So what this particular term virtual means? So virtual means something which is not physically present. And labs are a place where we have a particular set of equipments and we perform the experiments. So virtual labs are those kind of labs that are not physically present, but they have the same characteristics, same attribute as those of physical labs. Okay. And this particular platforms come under the umbrella project of NMEICT, that is National Mission on Education through Information and Communication Technology. Now, the question arises that why do we require this kind of platform? What is the need for it? So you see right now, this particular COVID pandemic situation has affected each and every nation across the globe. So what is happening? The users, they are unable to have an access to their physical labs. So this virtual labs, what they make you do, they make sure that while sitting at your own place, virtually you can see the experiments and you can explore them. But how this particular idea came into the concept? So what happened way back in 2009, when various professors from various IITs and other prominent institutes, when they visited various other engineering colleges, what they observed, the students, they were very good in theoretical knowledge. Theoretically, they were very sound. But once it comes to practical knowledge, they were somewhere lagging behind. So it was thought that something needs to be done so that the practical knowledge of each and every user across India could be enhanced. And that was the moment when virtual lab was born. So irrespective of a geographical location, each and every individual will get a good quality of education, and hence they would be having an equal opportunity to learn from all the resources that are present over here on this particular platform. Now, moving on to the next, we'll talk about the salient features of this particular platform. The best part is that as a user, you do not need to pay even a single penny in order to access this virtual labs. Yes, you heard me right. Virtual lab is totally free to use. You just require a system and internet connection. If you have these two things, you can access all these virtual labs anytime, anywhere, and that too totally free of cost. Two main points we should look out for is that it is developed in self-learning mode. Now, when I say it is developed in self-learning mode, so what I want to say that we have designed and developed this particular platform in such a way that a user can learn and understand a particular concept on their own without even the dependencies upon the other faculty members or the other resources. This particular platform will make sure that they learn and understand the concept. Next, we talk about innovative experimentations. Now, there are certain constraints on us in the physical labs, and a user, they cannot go out of the box in the physical labs. But yes, with the help of this virtual labs platform, innovative experimentations can be performed. So till now, more than 100 virtual labs have been developed, and each virtual lab consists of at least 5 to 6 experiments. So cumulatively, you have more than 500 virtual experiments to choose from. Let us now talk about motivational factors. Sorry. So what are the factors that will motivate the user to take up this particular platform? So the very first factor is the physical distances. Obviously, we are regularly talking about this COVID pandemic situation, and we have seen that the distance between the user and the physical labs, it has widened. So again, virtual lab is there for you that will particularly bridge the gap. Next is sharing of costly equipment. So we have observed that in the physical labs, is a particular component, a particular setup, and on that particular setup, 4 to 5 users are performing the experiment. Okay, because that particular setup is quite costly, so that is why it is not available to each and every individual. But what do we have done on this particular platform? We have made sure that those costly equipments are being divided to each and every individual, and those individuals have full access to all those equipments. Whatever the value they want to enter, however they want to make the connections, they have the complete freedom. Lastly is proliferation of quality of labs. So what you'll find over here on this particular platform, that on a single concept, there might be different labs giving you a diversified content. Okay. For example, we have a particular common topic, say sensors. On this particular common topic of sensor, you might find 2 different labs that will give you a diversified content, and that would ultimately enhance the quality of our labs that will help the users to learn and understand the concept. So this is the basic idea what you are seeing right now in front of your screen. Now, what do we have? We have this virtual labs. These virtual labs are over there on the cloud, and with the help of internet and your systems, you are the remote users. You can access them anytime, anywhere. Now, when this particular founding stones of this particular platform were being laid, now there were various objectives that were clear in the mind of the developers as well as in the mind of the professors. Now, what were those objectives? The very first objective was, wherever you are, you should be remotely able to access the labs, especially the labs that deals with science and engineering. Next, to cater the students. So by cater means that everything which is required to learn and understand the concept should be present over there at a single click. Third point, and the very interesting one, is to enable the students to learn at their own pace. I hope students are also present in this particular webinar, and we have observed that in the physical scenario, we have a particular time window for physical labs. And in that particular time window, we need to make sure that we have done the experiment, we have taken down the readings, and we need to submit the files as well. But what is happening in the real scenario, we have 2 categories of students. The very first one is fast learners, or we can say academically stronger. The other one is slow learners, or we can say academically weaker. So academically stronger or fast learner students, they quickly understand the concepts, they quickly perform the experiments, they take down the readings. But what about the slow learners? They require more amount of time to learn and understand the particular concept. But no, there's a particular time constraint over there in the physical scenario. So what is happening in the physical scenario? Most of the users, just for the sake of the submission of their files, they are simply copying out the observations. But the virtual labs, it gives them the complete privilege that you have ample amount of time to learn. There is no time foundation over here on this particular platform. You can take your own time, learn at your own pace. As a result, once you learn, you'll understand the things, then there might be certain questions that you might want to ask with the faculty members. And that particular curiosity would ultimately, again, enhance your knowledge level. Lastly, we say it is a complete learning system. Why we are saying? Because apart from the theoretical text, we have certain animations, we have certain videos. Okay, so all these things are present, and it is kind of an interactive environment. We'll see to it once we go for the demonstration part. So these are the difference between the physical labs and the virtual labs, and there are certain factors on which we have divided them. So the very first factor is cost. Obviously, if you try to set up a physical lab, you require huge monetary sum for that. You need to purchase the equipments, you need to acquire the space. But for which virtual labs, it is almost nil. You just require internet and your system. That's it. Availability, physical labs are not available to us every time, but virtual labs, they have been designed in such a way that 24/7, anytime, anywhere, you can have an access. Experimentations part. Now we need to understand that there are certain constraints on us in the physical labs. But why are those constraints applied to us? Because the institute, they are concerned for the safety of their users as their first priority, and as their second priority, they are also concerned for the safety of the equipment. But in virtual lab, as everything has been designed virtually, so it gives you this particular freedom that you can do whatever you want, and there would be an output for that. And from that particular output, you can also perform the innovative experimentations, and you can also learn the things. Lastly, we have this user experience factor. Once we talk about the user experience, please remember physical labs are the best because the real-time hands-on experience that we gain in the physical labs, nothing can beat that. But yeah, due to this particular situation and everything, virtual lab is second best, or we can say virtual lab is a complementary add-on. Even when the physical labs have started to, have been started in the past, or they are going on regularly, most of the students, what they used to do, first of all, before going for the physical lab, they spare their 15 minutes. They quickly go for virtual labs, perform the same experiment virtually, and then they enter into the physical lab. Now, what was the advantage of that? The advantage was that once they have performed the experiment on virtual labs virtually, they were very well aware with the setups that they are going to see, how to make the connections, how to take the observations, basic concepts. All those things were already clear to them. And as soon as they enter the physical labs, they simply go over there, perform the experiments, and then after that, there was a particular time that was left, and in that particular time, they can have an interaction with their faculty members. So these are the difference between the physical labs and the virtual labs. Okay, on our platform, you're going to find these three types of labs. The very first one is modeling and simulation-based labs. Now, these are those kind of labs in which what we have done, we have simply created a replica of a real-life process. For example, everyone has observed a waveform on a CRO, right? Just understand that observing a waveform on a CRO, that particular kind of lab we call as modeling and simulation-based lab. Next category is mission-based labs. Now, there are certain experiments, for example, Kirchhoff's current law, Kirchhoff's voltage law, in which we require exact numerical values. So those labs, those experiments we term as mission-based labs. Last but not the least, we have this remote trigger lab. Now, remote trigger labs are those kind of labs in which what you can do while sitting far away from a particular setup, you can trigger that particular setup in the real time. For example, you are right now located over there in Himachal Pradesh, right? And there's a particular setup that is only located in, say, IIT Guwahati, and you want to have an access to that, okay? This remote trigger labs, what they allow you to do, they allow you to see that particular setup which is very far away from you in the real time, and they allow you to enter the values in the real time and accordingly get the output. But yeah, with this great advantage comes a great disadvantage. What is the disadvantage? This remote trigger lab at a single time, only a single user can have an access to that. For example, if I'm using one of the remote trigger labs, none of you can use it at the same time. Whereas modeling-based labs and vision-based labs, at a single time, multiple users can have an access to that. Modeling-based and vision-based labs, they are more scalable, and remote trigger labs are not scalable. So the government, they give us a mandate that right now, let us forget about the remote trigger labs because they want to cater a huge number of students. So that is why we are focusing more on modeling and vision-based labs. So who are the intended users? I'll say anyone who has a will to learn, because we have plethora of resources on our platform, whether you are a college student, high school student, everything is over there present at a single click, and you can simply learn and enhance your knowledge level. Now, these are the participating institutes. You see, IIT Delhi is the main coordinating institute. Then we have the other 6 IITs and other esteemed universities across India. Now, professors and developers from these particular institutes have developed most of the labs that you're going to find on our platform. Now, what are the various broad areas in which virtual labs have been developed? So these are the broad areas that you can see in front of you. Starting from the very basic applied science, we have physical sciences, chemical sciences. Going on further, we have electronics and communication, electrical, computer science, mechanical. And yes, we are not stopping it over here. We are trying to explore more and more new domains in which virtual labs can be developed, and the user community can get benefit out of that. Now, how you can reach to our platform? Please remember this particular URL, www.velab.co.in. Now, this is the main URL, and over there it is a one-stop solution where you want to find all our experiments hosted. Okay, I repeat, everyone, I request every participant to please make a note somewhere, www.velab.co.in. Now, quickly summing up this presentation part. So what do we have about virtual labs? So consider virtual lab as a kind of a dish. Okay, And there are certain integrants we are adding into it. The very first integrant is on-demand labs. Whenever you feel like, labs are there for you. Second thing, everything is present at one place. Okay, content at one place. Third point, so I told you this particular platform has been developed in self-learning mode. So to support that, we have the self-evaluation part. Okay, after each and every experiment, there would be certain set of questions. Okay, you can answer those questions and you can evaluate yourself. Animations, obviously, actions, they have a louder impact than words. That is why animations and video tutorials have been added into the various experiments. And lastly, freedom to make mistakes. You can make sure that neither you are getting harmed nor the equipment is getting damaged, and you can still learn the things out. So if you add all these ingredients, we have a very good dish which is served to our nation that we call as virtual labs. We'll quickly see the impact of the project across our nation. So you can see under each and every participating institute, we have this nodal centers concept. Okay, so we have more than 1,000 nodal centers, and over 36 lakhs of students are regularly using this particular platform to gain the practical knowledge. I'll request every participant, please mute their mic. Okay, so these are certain glimpses of the workshops. So pre-pandemic situation, we used to go for the in-house workshops. So those are certain glimpses of that. Okay, AICT. Now, AICT was also quite impressed with virtual labs, and they have added this virtual labs in the model curriculum. I hope most of the faculty members, they might be aware about that. Yeah, for effectiveness, for example, today we have this particular small webinar, and most of the participants will get the basic idea. But if you really want to gain and if you really want to take advantage out of this particular platform, I'll request that after this particular webinar is over, you should at least perform few experiments on your own, and then only you would be able to realize the effectiveness. So that was all about the basic idea and the basic background about the virtual labs, which every participant should know, and I have just shared that. Okay. Now these are support and credentials over there. support@vlab.co.in. So if any user, any participant face any queries, they can simply put their mail to us. Now, without wasting any further time, let us quickly go for the demonstration part. Okay. So vlab.co.in. So this is our main homepage. I hope everyone can see to it. So let us understand this main homepage. We have this virtual labs logo, and just corresponding to it, we have the search engine. Okay. Now, for example, if you are a frequent user or if you are a new user and you are specifically looking for any of a particular lab, so in that particular case, what you're going to do, you're going to simply type the name of that particular lab, and then there would be a drop-down list, and from that particular drop-down list, you can simply go and explore. Now, after that, we have this other options: home, about us, our newsletter part, the new lab development, how you can develop a new lab, becoming a nodal center, the outreach portal, and so on. But let me tell you, your university is a nodal center under Virtual Labs IIT Delhi. Now, being a nodal center, you have certain privileges. Now, the very first thing is that as a nodal center, if you face any kind of queries while accessing these particular labs, you can simply put a mail to us on the support email IDs, and a concerned person from our side will get connected to you and will try to solve your queries. Next thing, everything, this particular activity, our webinar, whoever participants who have registered on that Google form, all this data will be directly shared with the Ministry of Education, because they are regularly screening our project, that who all are the participants, active participants, and which all institutes are regularly taking part in this kind of activities. Third one, and the very great one, is that till now, the participating institutes were only allowed to develop a lab. But now, being a nodal center, you have this particular privilege that you can also contribute towards this particular pan-India platform. Yes, you can also develop one of your virtual labs. Technical assistance would be given by us, okay? And then you can find the particular lab which you have developed over here with your institute name on this particular platform. So we talk about the basic part. If I just simply scroll it down, so we have the objectives, the philosophy, and the salient features again. Now, these are the broad areas in which virtual labs have been developed, okay? Now, what I'm going to do, I cannot demonstrate each and every experiment in this particular short span of time. So I'm going to try to demonstrate with a variety of different experiments that we have, and how as a user, and what are the various steps you need to take care in order to perform, or in order to use all these experiments problem-free, okay? So these are the broad areas that we are going to see over here. For example, let us start with the very first one. We have this domain that is electronics and communication. So what I'm going to do, I'm going to simply click on electronics and communication. Now, as soon as I click on electronics and communication part, I have the labs ready for use. You can just have a look, okay? Now, if I scroll it down, there are various names of the lab. Now, these all labs are ready to use. Okay. Now, for example, we have this a very basic lab, electric circuit lab. So what do we have? We have a name of a particular lab. Just corresponding to it is the name of the institute, participating institute, which has developed it. For example, right in this particular case, it is Amrita Vishwavidyapeetham. Now, after that, just below it, we have two other options, reference book and syllabus mapping. If I click on the reference book part, which book a user should refer to for this particular lab, that has been given. And if you go for the syllabus mapping, of which all universities the syllabus has been covered, that would be mentioned. Also, after that, you can see at the very bottom part, we even have the NPTEL video lectures link. So for example, if any of the user, they want to go for the theoretical in-depth knowledge for any of the particular lab, they can simply refer to this NPTEL video lectures. If you want to go for the practical knowledge, you have this virtual labs. Now, what I'm going to do, I'm simply going to click on electric circuit lab. Now, as soon as I click on electric circuit lab, you can see I have list of experiments in front of me. Parallel RC circuit, Thevenin's theorem. We're going to start with the very basic one, Kirchhoff's law. Okay, I'll simply tap on that. Now, as soon as I click on Kirchhoff's law, I have a complete learning system in front of me. Now, why I'm saying it is a complete learning system? Because of the various tabs that are present over here. Let us understand all these tabs. The very first tab is a theory tab. So you can see in the theory tab, we have the theory about the KCL and the KVL. They have been clearly defined. And once you scroll it down, you're going to see certain examples have been given so that each and every user is easily able to understand this particular laws. So everything has been clearly defined. I'm simply going to scroll it down. You can just see to it. And also we have this particular simulator that has been designed, that has been given. After the theory part, we have procedure. So in the procedure, you can see what are the various components that have been used. They have been defined. And just below it, a small procedure has been given. Now, after theory and procedure, you want to go for simulator. Okay, we'll cover the self-evaluation later on. First of all, we'll come for the simulator part. I'll simply click on the simulator. Now, please remember, in certain of the labs, you might require to sign in order to view the content. I repeat, in certain of the labs, you might be asked to log in, okay, in order to access the particular platform or to access the particular experiments. Please remember, IIT Delhi will not give you any special login IDs for that. Okay. For example, in this particular case, you are required to sign in. Now, what you can see, you have two options over here. Either you can freely sign up, or else you can simply click on the login option. And after you click on the login option, you can simply sign in using your own open ID, such as Google IDs, Yahoo ID. Okay. So what I did, I simply clicked on the login option. And after that, I'm taking the help of my open ID, such as Google ID, to simply sign in. I'll simply click on the Google part. I'll simply enter my credentials, and I'm over there in the simulator. Please remember, each and every system should be Adobe Flash Player must be enabled in order to perform the experiments over here on virtual labs. Okay, Adobe Flash Player and Java plugins, these must be enabled so that all the experiments can be easily explored. So I have I'm just reloading it, and then we will be simply going for the demonstration part. Okay, apart from that, for example, there are also certain experiments in which specific softwares would be required. Okay, so those specific softwares can easily be accessed, okay, and can easily be downloaded by you in the simulator tab only. A free downloadable link would be given over there. So it is taking certain time, not an issue. Let us go back because we are going for the maintenance part as well simultaneously. So there might be certain issues. For example, let me go for another, say, hybrid electronics lab. I'll go for a list of experiments over here. And then after that, for example, we have this design and implementation of various arithmetic circuits. Now, what do we have? You see, each and every lab, the template will remain almost same. You're going to find aim, pre-test, theory, okay, simulator part, procedure. So these tabs will remain same in each and every lab. I'll simply go for simulator, for example, and it says me click here for the simulator. I'll simply click on that. It says best using Google Chrome. Now, what we are trying to verify, you see, we have this particular half header, okay, and we have this truth table given over here. Now, we have these two inputs, input A and input B. For example, I just want to verify the truth table for half header. Okay, what I'm going to do, this is input A. This is right now, it is written off. I'll simply click on that. The input A is now turned on, and the input A is 1, and the input B is 0. Okay, and this is a half adder. Now, what I'm going to do, I'll simply go for the run option, and you can see after applying all this, I'll say the basic requirements, calculations from the half adder, we going to see the output. So what is the output that we are seeing? The carry output is 0, and the sum output comes out to be 1. So we can simply just verify this particular answer from the truth table over here. You can see input is 1, and the input B is 0, and the carry is 0, and the sum output is 1. Okay. Similarly, you can simply go for the subtractor part for the 4-bit adder. So please remember, this is a very basic labs I'm going to try to show to you right now, so that you can just first of all have the basic idea about it. Okay. Again, you can simply go for it. You can simply on, you can simply off. It is very easy. You just simply need to click on the particular inputs, right? I'll simply go back, and after that, we're going to have this particular post-test questions. So you can see certain questions are given over there, and just below it, certain options are there. You can simply select these options, and you can simply click on the submit button. If your answer would be correct, you would be told your answer are correct. If not, you will be told your answer is not correct. So see, in certain of the labs, you have this pre-test and post-test. Okay, please remember, every user should first of all follow the same methodology. Means what I want to say that being a user, you should not directly jump to the simulator part. You should go for aim, pre-test, theory, and then you should come for the simulator. Because I have observed that most of the users, just for the sake of visualization and demonstrations, they directly try to jump to the simulator part, and they do not go through the theory and everything procedure, and they are not able to fully utilize the simulator part. So that is why I just request you to please follow the particular method, the chronological order, and in that particular order, with the help of that, then come to the simulator part. So I think we are having certain issues over here in the basic electric circuit lab, not an issue. So similarly, that was one of the very basic lab from electronics and communication. I'll come back to the main home page. And for example, after that, we're going to go for, say, computer science and engineering. So if I click on that, again, labs ready for use. You can see new labs are coming up, HTML lab, data structures lab. Please understand that virtual labs covers 60% of the curriculum, and 40% of the curriculum is still out over there, which is not present in the virtual labs. So there might be a scenario where a particular lab that you are trying to access or you are looking for, that might not be present on this particular platform right now. Okay. So for that, what you need to do, you need to go and explore each and every domain, and then only you can realize that which all labs are present and which all labs are not present. And in the end part, I'm also going to showing to you that what are the new labs that are going to come out soon on this particular platform. For example, let us now start with computer science and engineering. And you see we have this problem solving lab developed by IIT Hyderabad. I'll simply click on that. So you see we have introduction, list of experiments, and so on. We'll simply go for list of experiments. For example, let us go for factorials. Now, what do you see? I'm not going to go again and again for the theory, objectives, and everything like that. I hope every participant have understand the importance of each and every tab. I'll directly come for the experiment part. I'll go for over here, go to lab. So you see over here, we do not require any login option or anything. I simply just come over here, simply click, and I have simply come to the simulator part. Let me just quickly zoom in. Yeah. Okay. Now you see, this is a simulator. There are certain features that we can see, certain options that are easily visible to us. For example, choose file to load. Okay. If you want to write your own program, you can browse the files and write a code over here. But we want to know what is the problem for which we are writing the code. For example, we have this problem number 1, and just adjacent to it, we have this I icon over here. I'll simply click on that. So it says that given a positive integer, find the number of digits in a factorial of a number. So we need to write a code. For example, if I have entered my input as 5, so the 5 factorial, the output is 120. Okay. So we need to make sure that we write a code, and for that, whatever the input we enter, so the number of digits coming out from that particular input, that should be displayed. Okay. That is our very first problem. For example, now many of the users, they might be easily able to write a code for that, but there are certain users or certain new students who are not able, or not very familiar with this particular idea. So what they can do, as I told you, this particular platform has been developed in self-learning mode. So they can take the options, take the help from the hint level. We have 4 hint levels, hint level 0, 1, 2, 3, and 4. Okay. If I go for the hint level 1, so 25% of the code has been mentioned for the users. If I go for the hint level 3, 75%. And if I go for the hint level 4, okay. So the complete code has been easily mentioned. So I'll simply just copy it down. For example, I'll paste it over here. I'll increase the pointer size. So you can see toggle editor, it has been enabled. I'll click on the compile option. I think I'm facing certain technical issues. Just a moment, please. We're going to switch to the other experiment. For example, let us go for string operations. I'll go for the experiment. Yeah. Again, we're going to see the problem. Okay, we need to write a code for the palindrome now. Okay. So for that, we need to write a code. So again, I'm going to take the help of this hint level. I'm going for the hint level 4, which gives me the complete code. I'll simply copy it down. I'm going to simply paste it over here. And after that, click on the compile option. I think it still has certain issues. I do not know why we are facing. Okay, so just see, this is a real-time scenario, real-time problem that we are facing. So in these kind of scenarios, you need to be patient because many a times we are trying regular updates and certain things are going on our server as well in the cloud. So those things you need to have certain patience for that. Okay. Let me just take you to another lab and let us see, can we have an access to that? We have this image processing lab. We're going to go for the list of experiments. Let me take you to image arithmetic. We have objective, introduction part, theory, procedure, experiment. So simply click on select image. We have a mosaic and select a particular image from over there. Now you can apply various operations on this particular image. For example, addition, subtraction, difference, multiplication, and so on. Okay. For example, I have gone with addition only, and the fitting you can go for auto scaling or the clipping part. So this is a secondary image, dull, bright, or gradient. If I click on the bright, you can see the image, secondary image turns out to be a bright one. And then you need to click on the run option. So you see this image processing lab, we are applying certain operations on the particular image. Okay. So what we did, we first of all simply click on the select image part, and we had a particular mosaic over there. We select a particular image from that, and then we can apply these various operations that have been mentioned. Okay. For example, addition, subtraction, difference, multiplication, and division. And we can also select the fittings, whether we want to see this as clipping or the auto scaling. And then we have select the secondary image, and we have performed the operation, and this is how we are getting the final output. So how we are getting the final output, what are the various prerequisites, concepts that have been involved, all those knowledge about all these things will be present over there in the theory part. Okay. So please remember, each and every tab has its own importance, right? Now after that, I'm going to go for the assessment part. We are going to have quiz over here. So you can see we have total 5 number of questions. Certain questions have been defined. We have the options. Select any of the options and click on the next, and you're going to go with the output. Lastly, we have this assignment tab. Okay. So certain questions are again given over here that can be practiced out. Similarly, this was the basics lab. If you want to go for the more complex lab, you have this wireless sensor network lab. We have this data structures lab as well. Software engineering. So all these labs, even our new labs, basics of HTML labs, that is also coming up, and that can also be easily used. Okay. Now I'll come back to the main homepage. And after that, for example, let us go for electrical engineering. I'm trying to demonstrate you one experiment from different domains, right? Again, the same labs ready for use. For example, let us go for another institute right now. Okay, say electrical machines by IIT Guwahati. And over here, we have this particular list of experiments. I'll go with rotating magnetic field behavior in 2 coils. Again, introduction, theory, procedure, everything is looking very much same. But once I go for the procedure part over here, in the procedure part, I'm going to see the various procedures that have been mentioned. And just below the point number 7, you're going to see we have this video tutorial that have been mentioned. You see, different experiments have different things that have been inscribed into them. So right now we have this video tutorial for this particular experiment. I'll simply click on the particular link. So this video tutorial that has been shown, the same steps need to be followed by us once we reach to the simulator part. I'll simply go back and I'll click on the experiment part. Please remember about the raw flash player. Okay, now one more query. Most of the participants, they might be easily able to understand that most of the web browsers, they are going to discontinue the support for the raw flash player in the late December. So as an answer to that, let me tell you, our developing team is already working on that. That is why we were unable to explore certain experiments, right? Because they were somewhat flash based, and our team is regularly updating them. And before the December, they would be, all these experiments will be running up and running, and that too without the dependence on the Adobe Flash Player. For example, you see, this is our particular setup that we have observed in the video part as well. We have these two coils. The video tutorial have easily explained the users how to make the connections, where to make the connections. So we are simply just gonna follow that. Click on one endpoint of the particular blue coil and make the connections. Same with the red coil. Then we're gonna go for the neutral part. Then we have the hall sensor. Simply click on that. Okay, now again, self-learning mode, you can simply check whether the connections that you have made are correct or not. It says right connection, you can proceed. Turn on the MCB, certain frequencies can be simply modified, okay? And accordingly, you are gonna see the various output, magnetic flux lines, vector field summation, graph on the oscilloscope. Everything is easily visible over here, okay? Now, after the particular part, experiment part, again, in the end part, certain questions are there. These questions can again be practiced out, right? So you see, I was giving an example of proliferation. So you see now we have electrical machines by IIT Roorkee. Scrolling it down further, electrical machines by College of Engineering Pune. Then again electrical machines by IIT Guwahati. So 3 labs goes by the same name, but yes, these have different components, different specifications, and they are giving you diversified content. Same was the case in the computer science and engineering, where we have 3 different data structures lab. Let me just quickly tell you. Yeah, so we have this data structures lab 1, data structures lab 2, and similarly a normal data structures lab. Okay, so you see the same lab name goes, but yeah, the way of representing the different experiments might be present in all the different labs. Come back to the main home page. So we have seen the basic experiment from these 3 domains. Let us now refer to the mechanical engineering as well. Simply click on that. Now, for example, again, we have the list of experiments over here, list of labs, and I wish to perform, for example, some metal forming lab by the Albag Institute. Okay. Now, again, if you go for the home option, you have the basic motivation part, basics behind the metal forming, the applications, right? Then if you go for the equipments, upsetting presses, extrusion presses are given. Then we have the various processes. Now, for example, a user, they want to learn all these processes. So what they're going to do, for example, I want to learn extrusion. I'll simply go for extrusion part. Now, I have a video, a simulated video in front of me at the very top, and just below it, the complete theoretical knowledge and the basic idea have been clearly mentioned over here. I'm simply scrolling it down, and you can just have a look. Okay. Now, after that, we have the simulation bench, where we have the simulation bench for aluminium and for titanium. So what we're going to do, I'm going to select for simulation bench for aluminium. Now, in this particular experiment, what do we have? We have a predefined set of these predefined set of parameters. And what you can do, you can simply select these parameters and then click on the submit button. For example, I'll quickly select all these different parameters, and after that, I'll click on the submit button. So you see, according to all those parameters, we are having the simulated video over here. Okay. Now let me just unmute it so that you can hear it out.
This process is hot extrusion process where different parameters are controlled.
So you can consider, for example, if any of the faculty members, they are taking classes in the, for example, it's online mode as well. So again, they can take the help of this virtual labs, and as a result, certain simulations are going on. So the users, the students, they would be having these simulations would having an impact on their mind, and with the help of these visualizations, they can easily capture the concept of extrusion. Also, you see this particular type of lab where you are just selecting the parameters, predefined set of parameters, and accordingly you are getting the output. These labs we refer to as modeling based labs. The previous labs that we did for example, electrical machines by IIT Guwahati, that was again, we can say modeling based labs as well, because in that everything we were selecting, making the connections, and accordingly we're getting the outputs. So similarly, after the simulation bench, we have comparative simulations. If you click on the comparative simulations, we have the 3 special cases. Okay, click on the case 1. So what is happening right now? 2 simulations are going on simultaneously. You can just have a look over here. And what is the change? What is the difference? I hope most of the participants, they can simply just have a look and they can make sure what is the difference that is happening. Then comes the application. For example, most of us, we are very well aware and we are very well familiar with the theoretical things, right? And mostly in the question papers, in the exams, we are being asked to write about the applications. We simply write the applications. But how can we explain all those applications? So if you ask those particular questions to the students, they might not be able to answer. But yes, with this virtual labs, we have even also shown that how this particular gall stick is made with the help of this extrusion process. Okay, so if you simply click on the gall stick part, again a simulated video is present over here, and you can simply just have a look.
A typical mold consists of shaft and knot without any seam with a handle for grip, a die for extrusion of shaft.
Now, similarly, you can simply refer to that. Now, next tabs comes with special cases. So we have 11 special cases over here. So these special cases consist of different shapes of mandrel that are not easily available to us in the physical lab. But yeah, virtually, we can make sure that with the help of these virtual simulations, we can make sure that all those special cases, special shapes can be considered and the output can be shown to the user. Lastly, as usual, we have the self-check quiz part. Again, certain questions are there that can be easily answered. If I go back to the mechanical engineering domain, we have the other labs. For example, you want to go for the higher, we have this virtual labs on mine ventilation, even the mechanism and robotics lab is also there. All these labs are present over here. You can simply explore them in the way which I'm showing you. What are the various steps that I'm telling you right now? You simply need to follow these steps and all these labs can be easily explored. I'll come back to the main home page. For example, I'm going to take you to civil engineering lab as well. So I'll simply click on the civil engineering part and we have the various list of labs over here. Okay. Now, please remember in the civil engineering domain, the labs developed by IIT Hyderabad. This is only and exclusively for civil engineering domain. In civil engineering domain, labs developed by IIT Hyderabad, for that you need to download a particular software that is VirtualBox. Okay. So how you can find that? For example, I'm over here in civil engineering domain, hydraulics and fluid mechanics lab by IIT Hyderabad. I'm going to go for list of experiments and say I'll go for Bernoulli's experiment. And over here, I have this simulation part. So you see, you have three options over here. So it says, please make sure that you have the prerequisites installed. Okay. So I'm going to go for the prerequisites. And over there, it says, we recommend the following smooth running of these simulations. And over here, we have the VirtualBox, and a free downloadable link for the VirtualBox is also given. So please remember, anywhere in any of the experiment, if any of the experiment require a particular software, so a free downloadable link of that particular software would be given by us in that particular simulator part only. The users, they can simply refer to this particular link, they can download the VirtualBox, and then they can simply explore the labs in the civil engineering domain for the labs developed by IIT Hyderabad. But right now, I'm going to take you to the other lab, Transportation Engineering Lab, which is a very new lab developed by NIT Karnataka. You'll simply want to click on that. Now, how this particular lab is different, for example, if I go for list of experiments, and if I go for impact test and aggregate, again, we have AM pretest and everything. But when I go for the procedure part, so what we have done in this particular lab, we have taken the snapshots from the simulator window, and all those snapshots have been put over here in the procedure part, and we have tried to make sure that the user understand each and every step that we are going to take. So you can see I'm simply scrolling it down, and every step has been highlighted, has been told to the user what they are doing and what needs to be done in the next step. So this same steps we need to follow once we are going over there onto the simulator part. Let me just quickly show it to you. I'm going to scroll it up. I'll come for the simulation part. Okay. It says impact test on aggregate. You can see over here we have the option. Next option, simply click on that. Now you can see regularly an arrow is blinking on this particular on option. It means you need to click over here. Simply click on that. Now just simply follow out each and every step. Please remember, the virtual labs, whatever the observations that we are getting on the virtual labs, we are getting under the ideal conditions, because in the physical scenario, there are many factors that influence our observation, but over here, ideal situations have been taken care and have been kept in mind, and according to that, you are going to get the output. So similarly, you can again just place it back, and then this is how you can make the connection. So whatever the steps that have been involved, those have all been already shown in the procedure part. Explanation for each and every step have been given in the procedure part as well as over here in the simulator part, that what is the exact process that is happening. Okay. Now, similarly, you can simply go to the next and simply perform all this complete the particular experiment. Now, after that, we have this post-test part. Again, set of questions are given over there, and you need to answer these questions and you can evaluate yourself. Yeah, references also are also given over here. Again, certain name of the various books and everything they have been mentioned, so that the user, they want to go for the more knowledge, they want to explore more, so they can simply refer to these particular options. Now coming back, I'm going to go for the main homepage again. Okay, so we have seen the various different labs. For example, let us go for, say, chemical sciences as well, for the applied sciences. And for example, let us again see whether these Amrita labs are working right now or not. Okay, so you can see the somewhere maintenance part is going on because we have the list of experiments opening up over here. And if I click on the acid-base titration, we only have the simulator and the other tabs are not present right now. Okay, so do not worry, they would be updated within a very short span of time. So I'm going to click over here for the simulator part. Yeah, so one of the very basic experiment, I think everyone has performed acid-base titration. So you can see the setup as well, the same setup we observe in our physical labs as well. So what do we have? We have certain variables over here, and you can click on the titrant part. You have the list of titrant to choose from. Then you have the speed of the titrant that can be very modified once the experiment has been initiated. Then you want to go for the titrate. Again, certain options, you can choose your option. Normality, you have a slider, simply click, drag, and you can simply just modify the value. Okay, so you can see measure and base, we are just modifying the values. Okay, the exact value can be modified. And the indicators, for example, sake of visualization, I'll go for phenolphthalein, and then I'll click on the start. So you can see the drops are falling out. There's a magnetic bit over here. I'm going to simply increase the speed of titrant. Now you can see drops are coming up a little bit faster, and also we are getting the exact result, exact numerical value, and also you all observe a color change. So you see we have observed a color change, the endpoint have been achieved, and also you are getting the exact numerical values. So you see same things are being observed by the user over there in the physical labs as well. Okay, and over here in the virtual lab as well. Accordingly, you are getting the output. So whatever the values you have entered, you have the numerical values with you. You're getting the exact volume of titrant that has been used, that has also been mentioned for you, right? So similarly, in this particular way, there are various labs under different domains that have been covered and that have been developed, so that the user, they can simply explore them. Now, I hope that these were the basic experiments that I wanted to demonstrate, and I have demonstrated that. Now we were talking about, I told you that I would be going to show to you the various upcoming labs, so that you can just make sure that whatever the labs or whatever the labs are there according to your own curriculum, whether they are going to be coming up, or whether you need to enter or you need to input your values to us or input your suggestions to us, that those particular labs are also required. So how you can do that? You can simply go for the new lab development part. Now, these are various bootcamp activities that are going on. In the bootcamp activities, we invite team from our nodal centers. We have our developers over there, and those developers tells the particular team that how the various experiments can be developed. So for example, we have this current proposals part at the very bottom. Simply click on that. Now you can see, you're going to find, see, these are the various upcoming labs with the name of the experiment and the name of the institute who is going to develop them. So you can simply scroll it down. You can see we have a huge list. All these labs, all these experiments are going to coming up and on this particular platform within a very short span of time. But yeah, if you are still not unable to find your lab in that particular scenario, what you can do, you can either put a mail to us on the support email ID, or else you can give your valuable suggestions. How you can give your valuable suggestions? You come back to the main homepage. We have this quick links part over here. So where we have the lab feedback form and the lab assessment form. So you want to go for the lab feedback form. Okay, you can give your valuable feedbacks. So all these entries can be simply filled out. A small questionnaire is given over here. Simply answer this and click on the submit button. After that, you can also give ratings to our virtual labs. For example, any of the lab you have used and you are not satisfied with the quality. Okay, in that particular case, what you can do, you can simply give ratings to our lab. Select any of the labs that you have performed. Okay, and then you have this particular pointer as options, and simply give your values and simply give your options. Okay. So whatever the labs that would be regularly receiving low ratings, what we are going to do with them, all those labs are going to be put under lab under maintenance part. For example, you can see this labs under maintenance. So these are those labs which have regularly received low ratings from the user. So we have put them down. We have taken the suggestion from the user community, and we are trying to make sure that we are able to implement all those suggestions. And then all these labs under maintenance will be again back into labs ready for use. So this was the basic idea, and this was the basic ways by which the user, they can perform the different experiments over here on this particular platform. So I think with this, I'm done with my particular session. Now I would be very happy to take your queries. If any person has any queries, please feel free to ask me.
Hello, Pratik, can you hear me?
Yes, please.
Yeah, okay, I'm Dr. HP Singh. Firstly, I want to compliment you. You have made an excellent presentation. Very well done. You know, we all faculty and students were completely spellbound on whatever being presented by you. The whole thing, the way you presented, it's awesome. Very good. So we are very happy about it, and good that you made everything clear. The basic fundamentals, what are the shortcomings, what are the labs available, what is under construction, what is the procedure, everything that you have mentioned, it's very good. I just want to know one or two things from you. One is that we are the nodal point. You're saying we are the nodal point. So what are the responsibilities of a nodal point, number one? Number two is, after this training has been done, what is next? Can we start using it, or is there going to be some agreement on this? Just please clarify these two issues too.
Please let me answer. So I would like to just rectify you. Your institute, your university is a nodal center. Now, nodal center is a particular institute which is designated and certified user of virtual labs. Now, for example, once you have submitted the EOI, expression of interest form, you become our nodal center, and the submission of EOI needs to be submitted. This particular EOI needs to be submitted after each and every semester. Now, after that, the responsibility of the nodal center is that they need to make sure that the students in their particular institute use this particular virtual labs platform and take advantage from that. Also, as a responsibility, after a particular semester is over, is a particular usage report which needs to be sent by the institute, the nodal center, to IIT Delhi, because that particular usage report will go to the ministry. What is the format for that? How you can calculate that? For that, we would be sending a mail to you. You can simply refer to that particular mail. Next thing is that now you are already our nodal center. You can also find your name of your institute over here in this outreach portal. And if you go for the nodal center part over here, and simply go for IIT Delhi, and simply start typing the name of your institute, you're gonna find your institute name over. Yeah, I think this is your institute, ICFAI University, Himachal, if I'm not wrong.
Right.
Yeah, and you can also see your status is active because you have submitted the EOI form. So you can freely and easily use all these virtual labs and make sure your faculty member and student use it. There is no other formality or no other documentation that is required. It is just that the EOI form needs to be submitted at each and every semester.
Wonderful. Are there any timings for these EOI forms? Are there any by so and so date this is to be submitted? Is there some timeline for the submission of EOI?
Yeah, so we would be sending you a reminding mail. Okay, at the starting of each and every semester, a particular mail will be drafted from our side, and you can simply refer to that particular mail. So nodal coordinator person is a person who would be simply acting as an interface between, for example, ICFAI University, Himachal Pradesh, and Virtual Labs Team IIT Delhi.
Okay.
Yeah.
Well, that's good. In our case, the main experimentation is going to be in the computer science engineering, civil engineering, physical sciences, and chemical sciences. These are the four areas that we are going to use your labs, virtual labs. So you also mentioned that, a lot of work going on as far as the physical and the chemical sciences are going on. A lot of development work is going on. So these are the four areas that we are going to use. And I think it's going to be very useful because it's all, expertise of IITs and top institutes who have worked on it and made available to us. And especially now, during the COVID time, when we are not able to get the students to do the practicals, this is going to be very, very good. So thank you very much. I think you have been very good and your presentation has been excellent. I will now request Pooja to take over and continue with the proceedings, whatever is left. Thank
Yes,
you.
sir. Thank you, sir. Prateek, sir, can we try one experiment on physical sciences?
Yeah, please. Let me go for the physical sciences. And okay, for example, let me show you the projectile motion if possible. Okay, mechanics of virtual labs. Yeah, projectile motion. Okay, we're gonna go for the simulator part. Right. So you can see, I hope everyone knows about the projectile motion. Please do not worry about the theory tab and every tab. Those would be really coming up within a very, very short span of time. So you see, now what is the advantage over here? Projectile motion in our physical scenario, when we are performing it, we have only a single environment to choose from. Okay, for example, we can only perform it on the environment of Earth. But again, virtual labs developed virtually. So you have the particular privilege that you can select the different environment. Whether you want to see for the Earth, or you want to see how this particular projectile motion will take place and what the value will be coming up over there on the say surface of Moon. You can simply select that. Okay. Now we have this cannon and you have certain parameters over here. Increase the velocity. Again, a slider is given. You can simply vary the slider. Just observe the change in the angle of the cannon as soon as I change the angle of projection. So you can see the value is simply, the angle is simply changing. Now I can also increase the cannon height. And now simply press on the fire option. So you can see it has been fired. And accordingly, you're going to see the output. And of course, you can also see that this particular smartwatch, this stopwatch that is also running up over here. And also you want to go for the result, you can simply click on the show result, the time of the flight, the maximum height and horizontal range. That will be simply presented to the user. So that thing can be simply performed it out. In this way, similarly, for example, for the optics part, say Newton rings and all, we have this laser optics lab as well. Okay, so these laser optics lab can also be performed. I'm just simply going to show you the simulator part. So you can see we have this particular microscope over here. We can select the medium, whichever medium you want to perform the experiment in. Select the light source. You can turn on the light on. So you can see radius can be verified, modified, microscope position. So you can simply just have a look, focus. And after that, again, you can simply go for the show result. So you see, these are the things, for example, you want to show them the student how the things can be performed and everything. These are how the labs have been developed, and this is how you can take the advantage out of it. Yeah, any further queries, ma'am?
Sir, one question from the student: why practicals of computer science engineering are not running?
Okay, yeah, let me give an example. So many of the experiments from the computer science engineering are not running because I told you regularly we are doing the upgradations right now. Okay, so there might be a scenario that a particular upgradation is running on at this particular moment. I assure you that if you wait for at least, I'll say right now it's approximately 4 p.m. If you wait for at least more half an hour, by 4:30, this particular experiment will again be up and running. Just in case many of the users might be having these queries that what we'll do, just in case any of the experiment is not running, how are we going to report it out, how are we going to solve our queries. So all those, every participant, let me tell you, if you see any of the particular experiment not running, what you can do, you can simply take a snapshot, okay, and then please put a mail to us on support@vlab.co.in. Also, please remember to mention your name and your institute name once you are writing the mail, because as soon as we check it out that we have received a mail from a nodal center, then we'll try to solve the query as soon as possible. I'm simply going to have word with my engineers and the developers part, and I'm going to ask them what is the problem behind it, and they're going to rectify it very soon. You don't need to worry for that. Any further query, please?
So right now, no more queries. So I hope students got idea that how to make use of virtual labs now. So On the behalf of ICFAI University, Himachal Pradesh, I take this opportunity to propose vote of thanks to IIT Delhi Virtual Labs. At the outset, I thank Mr. Prateek Sharma, Banter Virtual Labs, IIT Delhi. We are really enlightened with your knowledge, sir, and with your presence. We are thankful to our Honorable Vice Chancellor, sir, for their motivation, and I would like to thank our HOD, sir, for his support. My heartfelt thank you to our students for the active participation. And with these warm words and a kind message, we move to the end of today's workshop. Thank you, sir. Thank you for joining us.
Thank you so much for giving your valuable time. Thanks to everyone, and I hope everyone remains safe and healthy at their place. Thank you.
Thank you, sir.
इसको एक तो पूजा, एक पंकज दीवान, एक भारद्वाज, एक योगेश, इन चारों को बुलाओ। पहले चाय पिला रहे हो? पहले चाय पिला दो।